Should we eat meat? You know, it feels like such a simple question, right? But it's easily one of the most polarizing debates of our time. This one choice connects our personal health, our deep evolutionary past, and the future of our entire planet. Okay, let's dive in and really unpack this.
So yeah, let's just put it out there. This question forces us to weigh who we were, our evolutionary history, against who we are now in this modern reality. Are we biologically programmed carnivores, or is meat eating a habit our planet just can't afford anymore?
Well, according to the scientist Vaclav Smil, there's no simple yes or no here, not even close. The real answer is a story of trade-offs, of nuance, and some pretty surprising facts. And that's the story we're going to unpack piece by piece.
To even get started, we've got to know what we're talking about. It seems so obvious, but the definition of meat itself is our first big clue that things aren't as clear-cut as they seem.
Okay, so scientifically speaking, this is it. Meat is the skeletal muscle of mammals. But is that what you think of when you order chicken? It's funny, back in the 1950s, many American housewives didn't even consider poultry to be meat at all.
And the confusion doesn't stop there. Take the USDA, for example. It classifies all livestock, including pork, as red meat. But in the culinary world, it often depends on the animal's age. So veal is considered white, but duck is red. There's just no single universal rulebook.
Nutritionally, meat is an absolute powerhouse. It gives us that high-quality protein that's vital for growth, especially for our brains, along with easily absorbed iron and zinc that are way harder to get from plants. But of course, there's the other side of the coin. Some cuts are high in saturated fats, and there's a growing scientific consensus around the health risks of frequently eating processed meats. You know, things like bacon and hot dogs. So, if meat is such a mixed bag, why do we eat it at all? To answer that, we have to look back, way, way back, to a crucial trade-off our ancestors made millions of years ago.
This is the core of what's called the expensive tissue hypothesis. Here's the deal. Your brain is an energy hog. It uses about 16 times more energy per pound than your muscles do. So for our brains to get bigger, our bodies had to find that energy somewhere else.
And this is the evolutionary bargain our ancestors made. By eating energy-dense meat, they didn't need these massive guts to digest tough plants all day. So as the gut shrank, all that freed up metabolic energy was redirected straight to power a bigger, more complex brain. It's pretty wild to think that, in a very real sense, meat may have helped make us human.
But, and this is a really crucial point, this evolutionary adaptation happened when meat was a rare prize. For the vast majority of human history, from ancient Rome to 19th century Europe, most people ate almost entirely vegetarian diets. Meat was for the rich or for special occasions.
Which brings us to today. In just a few decades, we've gone from meat being a rarity to an absolute global juggernaut. How on earth did that happen so fast? The key concept here is something called the dietary transition. It's a pattern that's incredibly predictable. As countries get richer, their populations start eating more meat. It's a status symbol, a sign of prosperity. And there is no better example on the planet than China. I mean, just look at this chart. The country's economic boom after 1980 triggered one of the most rapid and massive shifts in diet ever recorded in human history. What was once a nation of subsistence peasants became a primary driver of global meat demand. But this massive expansion wasn't free. Producing billions and billions of animals for food comes with a significant environmental bill, one that we're only now starting to fully calculate. Let's just consider the feed. Beef is notoriously inefficient. This number, 7, it represents the kilograms of feed, often grain that humans could eat ourselves, required to produce just 1 kilogram of beef. That's a tough equation for a growing planet. And then there's the water. Now, the real story isn't how much a cow drinks, but the virtual water needed to grow its feed. This number, 1,000, is roughly how many liters of water it can take to grow just a single kilogram of corn for animal feed. That's a lot of water.
But here again, Smile urges us to see the nuance. A lot of that water is rainwater, what scientists call green water, falling on pastures that are too hilly or rocky to grow crops on anyway. In this case, cows are brilliantly turning something we can't use, grass, into high-quality protein, so it's not always a simple case of them competing for our resources.
So, what about food miles? We often hear that eating local is the key to saving the planet, but the data reveals a really different story. Transportation is only a tiny slice of the emissions pie. A whopping 83% comes from the production phase. We're talking methane from cows and fertilizers for feed. This means what you eat is far more impactful than where it comes from.
So, we're left with this incredibly complex picture of nutritional benefits, an ancient evolutionary legacy, and some very serious environmental costs. Where do we go from here? Well, Smils suggests a path he calls rational eating.
When it comes to health, the picture is, yet again, nuanced. Studies show vegetarians often have lower risks for certain diseases. But it's also true that the world's longest living populations, in places like Japan and Scandinavia, are not strictly vegetarian. They're moderate omnivores. The crucial point seems to be that there isn't one single best diet for longevity.
So what does this rational approach look like in practice? Well, it means being mindful of the trade-offs, prioritizing more efficient meats like poultry over beef, and just consuming less overall. Treating meat like a luxury, not a staple, much like our ancestors did. It also means valuing cattle for their unique ability to graze on non-arable land, and crucially, not wasting the food we produce. Ultimately, there's no single prescription here. We've explored the definitions, the history, the science, and the costs. The question isn't just, should we eat meat, but really, how should we? Knowing what you know now, the real question is left for you to decide.